All right, welcome to lesson 9.2, the law of cosines. So in the last lesson, we showed how we could use the sine function to solve triangles that are not that do not have right angles in them. And so we're going to continue that lesson now with the cosine function because there are certain cases where the law of sines works great. For example, if you're given two angles and a side, so angle side or angle side angle, then the law of sines works fantastically. But if you have more sides, for example, side angle side or side side side, you really need another rule to apply because the law of sines doesn't work for those situations. And so now we're going to be using the law of cosines. And so the law of cosines looks like this. And yes, it is a lot more complicated than the law of sines, and I'm sorry, but it's not as bad as it looks. So our standard form, if I want to find a side, for example, side A, it would be a squared equals, and then the other two sides, b and c squared, minus 2bc cosine of the angle opposite side A. And if I'm trying to find an angle, again, I would use the just the same equation rewritten to solve for cosine A. We'll also be talking about Heron's formula as well to find the area of a triangle that is not a right triangle as well. But before we get to that, let's do a quick proof of the law of cosines, because I really do find that these are easier to understand if I know where these come from, because I'm not a big fan of memorizing formulas, but certainly this is a good one to try to commit to memory. So if I have a triangle, again, I don't have right angles in there, but I'm going to go ahead and drop a perpendicular line F that's perpendicular to the base B. And that divides B into two different line segments, D and E. And then that vertical line that's perpendicular to B is going to be called F. Okay, so this is what I've got. So from here to here is D. From here to here is E, and then that vertical line that is perpendicular. It looks like my little perpendicular symbol didn't move when I moved my triangle. So again, this is a perpendicular line here, F. So going then, if I have those angles A, B, and C, then I could say that the cosine of angle A, cosine A, equals, and then remember it's adjacent over hypotenuse, and so it's going to be adjacent is D over the hypotenuse, which is C. And if I rewrite this for solving D, then D would equal C cosine A. Okay, all right, so now what is the length of E? Well, in terms of B and D, we could say that E, since B equals D plus E, then E would equal B minus D, right? And we already know that D is C cosine A. So then this length here, E, all right, we're talking about this length right here, E equals this total line B minus this length D, which we already said was C cosine A. Okay, so far so good. Now, what about this angle? Let's do the sine of A. So sine of angle A is opposite, right, over hypotenuse. And so that's F over C. And so rewriting then F equals C sine A. And going from that, then I have, for the triangle, let's do the Pythagorean theorem for this triangle inside here. So this triangle, AFE, that triangle has, using that Pythagorean theorem for that, because this is now a right triangle, right? So A squared equals f squared plus e squared. And now I'm going to go ahead and substitute some of these in here. So like f is c sine a, right? So a squared equals c sine a, and then that whole thing is squared because that's f squared. And substituting in for e, this equation plus b minus c cosine a, and that whole thing is squared. So now we get fancy with the math, right? So I'm going to go ahead and distribute this square. So this is c squared sine a, or sine squared a, plus, and now I FOIL this, right? This is b minus c, and then the whole thing is squared. So it's b minus c times b minus c. And so that comes out to b squared minus 2bc cosine a plus c squared cosine squared a. Okay, so now what can I do? I can combine some terms together here. I'm going to take the c squared cosine 2a and add it to the sine squared. And so that's going to give me, and if I factor out the c squared at the same time, and I know I'm skipping a step in here, I hope that doesn't confuse. So I'm going to combine this, and I'm going to factor out the c squared. Okay, so I get c squared times sine squared a plus cosine squared a. And then all of that is plus b squared minus 2bc cosine a. And of course, you remember from your trigonomic functions that sine squared plus cosine squared equals 1. And so 1 times c squared then just gives me c squared. So now I can rewrite this formula. Right? So this just becomes 1. And so my final formula then is a squared equals c squared plus b squared minus 2bc cosine a. Now, don't panic. I do not expect you to be able to recreate this. I just wanted you to see where it comes from. Those of you going on to some higher math later on, this will be useful to you to understand how this equation is derived. But if you want to just memorize it coldly, which is probably the best way for you, then do that. But you definitely need to memorize this formula. So rewriting this formula, and by the way, this a squared equation, this is what we just created, works for all three sides, okay? And you'll note the only difference here, if I have A, then over here I've got BC and BC. If I have B, then it's the AC, right? So whichever side is missing goes over in this one over here, and then of course it's the opposite angle. Now I could also use this formula to find the angle A by just rewriting this or solving this equation here in terms of cosine A. So cosine A would equal this expression right here, and B and C. So let's get into it now, and it's plug and chug time. We're going to use the law of cosines to solve this triangle. And so this triangle here has got the three side lengths, A, B down here is 19, and C is 14. And I need to start by finding one of the three angles. And once I've found one, I'm going to find the second one and then use the fact that all add up to 180 to find the third side. And so the law of cosines gives me that cosine of angle A equals B squared plus C squared minus A all over 2BC. So let's plug those values in. So B is 19 and C is 14. So cosine of A equals 19 squared plus 14 squared minus, oh, this should be squared. A squared is 10, no, 8. So minus 8 squared. All of that over 2, 19 times 14. Now, keep in mind that cosine, if it's greater than 90 degrees, it's going to have a negative value. And so if you end up with a negative cosine A equals some negative value, don't panic. That is okay. In this case, I'm not going to, but it is all right. So this is just plug and chug into a calculator, and I'm going to get a value. And I'm going to take the arc cosine of it, and I'll just do one of these. I don't really want to do all of these on the calculator here, but let's go ahead and do that. So again, cosine, so I'm going to take 19 squared plus 14 squared minus 8 squared. And then take that value and divide it by 2 times 19 times 14. And you get 0.92. And so now arc cosine of that value is 22.07 degrees. I think I'm going to go ahead and, well, let's go ahead and make that 22.1 degrees. Now, I'm going to go to the next point, and I could pick either B or C, but we'll go ahead and use C here. So cosine of C. And remember, my other two side lengths are 8 and 19. All right, so this is going to be 19 squared plus 8 squared minus 14 squared all over 2 times 19 times 8. We use these two numbers here. It makes it easier to remember when you plug these in. And that number is going to come out to 41.1 degrees. All right, so then the fact that all three angles add up to 180, so 180 minus 41.1 plus 22.1 is going to give me a third angle of, let's see, that's 63.2. And so that's going to be 116.8. All right, so that's all three of the angles that go with this. Now we use the law of sines to find this triangle. Well, here I'm given one of the angles at 115 degrees and two sides. And so there's a lot of different ways I could approach this, but I'm just going to start by finding this opposite side over here, A. This is little a. And so A squared equals B squared plus C squared minus 2BC cosine angle A. So let's plug and chug. So A squared equals 10 squared, 15 squared minus 2 times 10 and 15, and then cosine of 115 degrees. And I'm not going to put that into the calculator for you. You can figure that out. I end up with A squared, or A equals 21.3. And this is centimeters. Same units that we had here. So now A equals 21.3 cm. Now I could use I need to find the other angles. I need to find at least one more angle here. And so picking just let's do angle C right here. So cosine of angle C equals, and that's going to be 21.3 squared plus 15 squared minus 10 squared. And that's all over 2, 21.3, and 15. Okay, and plug all that in, and you do the arc cosine of that value here, and you're going to get 25.1 degrees. And so now that I have this angle at 25.1 degrees, then this angle right here can be found by subtracting 180. And that's going to give me 39.9 degrees for the third side. If you were off by a rounding error of a tenth of a place in here, I'm not going to mark those wrong. And the district for their quizzes also kind of have a little bit of slop by being multiple choice. And so it's easy to make sure you get the right answer there. Okay, let's try using Heron's formula to find the area of a triangle. Well, I didn't draw myself a triangle here, but I'm going to go ahead and throw it in. And I really don't need it for this anyway, because the formula just takes these three side lengths. So 43, 53, and 72. And so I start off by finding this value S, right? So this S equals all three sides added together and divided by 2. So 43 plus 53 plus 72, all divided by 2. And plug that into our calculator, and we get 84. So plug that now into our area formula, and the area is the square root, and it's this massive equation, right? So it's 84 times 84 minus each of these values. So minus 43, 84 minus 53, 84 minus 72. So now I've got that. So my area now equals, and again, it's just plugging into the calculator and coming out, and I get an area of 1,131 meters squared, or cubed, yeah, squared, because these are all meters. Okay, so I have a baseball diamond, and the pitch on the baseball field is 60 feet 6 inches from home plate. So let's call that 60.5 inches. And the bases are 90 feet apart, and they form a perfect square. So what is the distance from the pitching rubber to first base? And we got to remember, I'll go ahead and put that square in here. You got to remember that the pitching rubber is not in the exact middle, okay? So it's somewhere over here. And so this forms a triangle, and it's not a right triangle here. So this is not a right angle, okay? And so that triangle is 90 feet on the hypotenuse, or, well, 90 feet on that side. Remember, it's not a hypotenuse. We don't know what this length is. Let's call that A. And then this side here is 60.5 feet. And so what can we do to find side, well, this side A? Well, what else do we know about this square? Well, this is a square, right? And if we go and bisect that, then we know that this angle here is 45 degrees. So now I've got side angle side, which we can use now to the law of cosines in order to solve. And so the law of cosines for this problem, we want to find side A, so A squared equals, and my side B here is going to be 60.5 plus 90 squared minus 2 times 60.5 and 90.90, and then cosine of 45 degrees. All right, so that's all plug into the calculator stuff. So if I plug that into my calculator, you're going to get an answer of 63. So A equals 63.72 feet. Okay, that's it. That's our last problem.